Hello, everyone. We are going to study the periodic table of elements today. So if you'll open up your study guides and turn to lesson 4, the periodic table. All right, everyone should have their study guides out to lesson 4, the periodic table of elements. All right, we're going to look at how the periodic table, or our modern periodic table, is organized today. This is a very important tool. We will be using the periodic table all the time in this class. And so it's very important that you understand how we have organized the periodic table, what information that we can get from the periodic table. And this is an ongoing process throughout the year. There is so much information from the periodic table. Is quite a remarkable document, okay? So let's start out with the basics of the periodic table, how it's organized, and so forth. So everyone should have a periodic table. And in fact I would have this periodic table out that I've given you so that you can refer to it as we have our discussion today on the periodic table. Now this table is for you to mark on, to organize it in the manner that could be useful for you to study how the periodic table is organized. So I would use it, okay? You can always print out your own periodic table as well and use that and mark that up as well. All right, now you will always have access to a periodic table on every unit exam that we take. I will be providing a periodic table for you for each test that will be included with the actual unit exam. And it will be basically, the periodic table will have the element symbol. It will not include the element's name, but it will include the symbol, the atomic number, and the atomic mass, okay? So it'll be pretty basic. So you have to have a very good understanding of the periodic table structure and organization to have it useful to you on the test, okay? All right, so now most of you know that the periodic table is organized into columns and into these horizontal rows here, okay? So vertical columns and horizontal rows, okay? So in your notes here, a vertical column on the periodic table, they're called groups or they're called families. So if you look at your periodic table here, see if I can show you this. This right here is a group. This is a group as well. So these columns on the periodic table consider groups. Here's a group here, okay? So this right here is group 1 on the periodic table, and this is group 2, and so forth, all the way to group 18 on the periodic table. So there are 18 groups on the periodic table, 1 to 18, all right? Elements are arranged in groups or in families based on their chemical properties and chemical reactivity. Okay, so that's really important to know and understand for the test, that we're looking at chemical properties and chemical reactivity for elements that are placed in the group. So what do I mean by that is the elements that are placed here in group 1, the reason why they're grouped together in group 1 is because they have very similar chemical properties and reactivity. And group 2 right here they are grouped all together because they also have their own unique but similar chemical and physical chemical reactivity and properties. Okay, so that's why elements are in a column, okay, or in a group or a family, is because they have similar chemical properties and reactivity. All right, now what about the horizontal rows that go across? Those are known as periods, okay? And on the periodic table, there are 7 periods going across. So up here, this is period 1, and then going across here is period 2, and then period 3, all the way down, you got 7 periods on the periodic table. Now, the elements are arranged in a period going from left to right, in a period going across by increasing atomic number, okay? So as we're moving across from left to right, there is an increase in the atomic number. And that's why elements are arranged in this way, going from one element to the next across, is by that increasing atomic number. So keep that in mind as well, all right? All right, so we have a periodic table here in your notes, and we're gonna fill out a few things. So up at the top here, right there, are the group numbers. Okay, so this is group 1, this is group 2, group 3, group 4, 5, 6, 7. You know, you're seeing this hopefully. 6, 7, 8, 9, 10, 11, 12, 13, all the way to group 18 on the periodic table, the last group. And remember that the reason why these elements are grouped together, the reason why all of these elements are grouped together in orange right here, is because all those elements have similar chemical properties, or the reactivity is very much the same. These elements right here in group 17, they're all in the same group because they all have the same or very similar chemical reactivity, okay, and so forth and so forth, all right? Now, periods. So the period number is usually found on the sides here. So this is period 1, period 2, period 3, period 4, 5, 6, and then finally period 7, okay? So periods run across, so this is period 1. Period 1 contains hydrogen and helium. Period 2, all the way from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, okay? So again, periods go across. Period 3 includes sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon, okay, and so forth and so forth. So you have these 7 periods. Now, as I mentioned, by period, it is arranged by increasing atomic number. So the atomic number is located at usually the very top of the symbol in the periodic table. So for hydrogen, it has an atomic number of 1. For helium, atomic number of 2. So an increase going left to right. And then we start back to group 1 again. And lithium has an atomic number of 3, beryllium 4, 1, 3 and 4, and then 5 for boron, carbon 6, nitrogen 7, oxygen is 8, 9 for fluorine, and finally 10. So again, all we're seeing going across left to right is an increase in this atomic number. We can see the same thing in period 3, an increase in atomic number, period 4, an increase in the atomic number all the way across, okay? So those 2 things you need to understand is that in groups or families, we organize by chemical properties or reactivity, and in periods going left to right is by increasing atomic number, okay? Hopefully that is clear. All right, so kind of just mentioned the atomic number where we find it on the periodic table. So if you take an entire block, an elements block, right, out of the table, for carbon, for instance, it will have the symbol C for carbon, and then up at the top is usually the atomic number on most periodic tables, and then you have below the symbol the atomic mass. And we'll talk more about the atomic mass in coming weeks and so forth. We will be using the atomic mass quite a bit. It's an important number. It's one that you don't necessarily have to memorize for all of these elements, but it is something to be familiar where it's located at on the periodic table so you can use it. The atomic number, same thing. You don't have to memorize the atomic numbers for an element. You just need to understand what the atomic number is, which we'll talk about more coming up here. Where it's located out in the periodic table for an element, because it's super important for that element, vital for that element, okay? So again, you don't have to memorize atomic numbers. What I do expect you to know for the periodic table, though, is to know the element symbol and the name of the element. And of course, the periodic table I've given you has the symbol and it has the name. All right. Now, the periodic table on the AP test does not give you the name at all of the element. So I am requiring you to know the name and the symbol for these elements on the periodic table. Okay. So you really, if you have not already started memorizing the names and the corresponding symbol, to do so. Remember, as we talked about earlier, that the element symbol always begins with a capital letter. And if there's a second letter, it'll be lowercase, right? So for instance, magnesium begins with a capital M and has a lowercase g, okay? Oxygen is just capital O, carbon, capital C, calcium, capital C with the lowercase a, you know, zinc, capital N, capital Z, lowercase n, okay? So just always remember, you must capitalize the first letter of the symbol in the element, all right? All right, so let's go into what are some essential vocabulary words here then. The atomic number, by definition, for an element is the number of protons of that atom or element, okay? So that is really super an important idea. So if we ask you, what is the atomic number of like beryllium, you would say it's 4, and it has therefore 4 protons in its nucleus, okay? So the atomic number is used to identify the type of atom or element, okay? If you alter the number of protons, you alter the identity of the element or atom, okay? That's super important concept to understand. All atoms or all elements are identified by its atomic number or number of protons. And that's why you'll find that number in each of the corresponding element boxes on the periodic table, because it is that number that identifies what the element really is. And once we say like, oh, the element has 6 protons or an atomic number of 6, that element will always be called carbon, or the atoms will always be called carbon atoms because of the 6 protons, right? Now, atomic mass by definition, is the mass of an atom expressed in atomic mass units, okay? Atomic mass units is abbreviated as AMUs, okay? AMUs, atomic mass units. Atomic mass units are used by chemists and physicists in order to make the mass unit a little easier to deal with. In reality, the mass of an atom is so small. I mean, it is just super, super, super tiny. And so we use a specific mass unit called the atomic mass unit to make it easier for us to work with these atoms, okay? So we'll talk a lot more about the atomic mass units and the atomic mass later date, okay? Now, down here is an important point, okay, that I want to make note of. It's approximate equal, okay? So the atomic mass is approximately equal to the number of protons and the number of neutrons in an atom. Now, the total number of protons and neutrons in an atom is known as the actual mass number, okay? And the mass number is a whole number and not a fractional number like the atomic mass is, okay? So if you look, for instance, at oxygen, the oxygen usually has something like written down maybe on your periodic table 16.00, okay? And that is because the atomic mass has a fraction to it, whereas the mass number, would just be 16. It would be a whole number, okay? So there is a difference, and we'll point those important points out later, okay? All right, so just to share briefly, again, I think you get the idea that the atomic number is up here, followed by the bottom number right there is the atomic mass. So there's the atomic mass of carbon. Notice that here that you can see the fraction on all of these, like oxygen 15.999. But again, for oxygen, if we were to look at its mass number, we would just say it's 16, okay? We'll understand more about that in the coming days, all right? So each box has an atomic number and an atomic mass written down. All right, now, what else is important about the structure or the organization of the periodic table? Essentially, the periodic table is divided into three main categories. And those three main categories are metals, nonmetals, and metalloids. And you need to know where those categories are located at in the periodic table, and we'll show you in a minute. Now, the majority of the elements found on the periodic table are classified as metals. All the metals at room temperature are solids, with the exception of mercury, okay? And mercury at room temperature is a liquid, okay? So if you look at, here's a mercury at room temperature, and it's naturally a liquid at room temperature. Now it will form a solid, but you have to lower the temperature quite a bit to get it in the solid state. In the gas state, when you get liquid or you get mercury into the gas state, it's very dangerous. The vapors of mercury are very toxic. That's what makes mercury so terrible, okay? But here it is in its liquid state at room temperature, okay? But it's the only metal that we find at room temperature that's a liquid. Most of them are solids like copper. Copper is a metal, elemental metal, and it's a solid. Bismuth, I've showed you this before. Bismuth, which is a metal, is also solid at room temperatures. Okay, really cool element. And then europium, I also showed you europium earlier too. And this of course is a metal, a rare earth metal, and it is also solid at room temperature. Okay, let you look at that a little bit closer up. Okay. See mercury a little bit closer. I think mercury is so much fun to play with, but it's very toxic, so be careful. Okay, you can do this all day. All right. All right, so some things to record here in your notes about the periodic table. So where the three classification of elements are located. So there is a specific line on the periodic table, and that line is important for separating the metals and the non-metals especially. So this dividing line is like a staircase right here. I'm kind of drawing it here. You should probably draw it in black as it's written, but just kind of tracing that line right there, okay? That, again, is the division line or staircase between the nonmetals, which are found on this side of the periodic table, on the right side of the periodic table, and then on the other side is the metals, okay? And the metals also include all of these elements down here. These are all metals as well, okay? So, as I was mentioning, most of the periodic table is made up of metals. So you can say from here, here's the dividing line, all the way over is metals, and then from this side is all non-metals, okay? Now, the metalloids. The metalloids, they kind of sit on top of this dividing line here, and most of them are in yellow. You can see on this periodic table. The metalloids, the ones that you need to know for the test are boron, silicon, germanium, and antimony. Those are the four metalloids you should be familiar with for the AP test. So boron sits right here, silicon, germanium, and antimony, okay? Those are the ones I really want you to know. Arsenic is often categorized as a metalloid, but it also can be sort of more of a non-metal and so forth. So I don't know, just be aware of that. Also make note that hydrogen is really, even though it sits over here on the metal side, hydrogen really is a non-metal, and that's really important to note. It's here. So why do we put it way over here in group one? Because remember that elements are organized into groups of families based on similar chemical properties. And hydrogen has some similarities in its chemical properties as the rest of these metals: lithium, sodium, potassium, rubidium, cesium, and francium. Okay, so that's why it's placed over there, even though it is really a non-metal. Sometimes, and you might want to make note of that, sometimes, oops, draw this a little bit better. I'm going to draw a box here. Some periodic tables often add hydrogen as well right here above fluorine, okay? Because hydrogen does fit very nicely as well above fluorine, right next to helium. So most periodic tables don't do that, but some do. So just think that hydrogen could be in a couple of different places. Again, period number, right? 1, period 2, period 3, period 4, period 5, period 6, and period 7. And then we have the group numbers up here, right? We've kind of gone through that. Just kind of placing out the periodic table a little bit, how it's structured and organized. All right. Dividing line, do you need to know where that is? Absolutely. I always remember that it starts between boron and aluminum. And once you draw that line between boron and aluminum, just make a staircase all the way down from there, and you will have your dividing line. Your dividing line will not be on the periodic table that you have for the AP test or the unit exams. So very important to know where that dividing line is, where the metals are, where the nonmetals are, and the metalloids, okay? Very, very, very important. All right, some more things to make note of. Non-metal elements can be solids, liquids, or gases at room temperature. Remember that we earlier stated that the metals are all solids at room temperature other than mercury, but non-metals can be all three, just depending on the type of element we're looking at, okay? Like bromine, for instance, it's a liquid at room temperature, okay? Whereas iodine is a solid at room temperature. And fluorine or chlorine are both gases at room temperature. So nonmetals, depending on the nonmetal, it can be a solid, liquid, or gas, okay? Again, remember that hydrogen is a nonmetal. And then we have the list of metalloids that, again, I want you to have down and memorize for our class: boron, silicon, germanium, and antimony. All right, so to get finishing up here with this lesson, I just want to go through this table, essentially. The properties, the reason why we separate these elements into these three categories, metals, nonmetals, and metalloids, is due to the properties, specific properties that are different, okay? So here are some physical properties, and then you have some reactivity as well that you need to be aware of. So metals typically have high densities, high melting points, very high boiling points. They do conduct electricity, they conduct heat, and they're malleable. And the term malleable means that they can be bent. We can bend them, we can shape them. So they're very useful that way. And their reactivity is they like to react with nonmetals. The nonmetals are just the opposite. Look at this: low densities, low melting points, low boiling points. They will not conduct electricity usually. They will not conduct heat usually, and they're brittle. They're not malleable. If they're solid, they're brittle solids, and they crumble into small little pieces into powder. Okay, so they're very brittle, and they're reactive with the metals. So metals and nonmetals are just opposite of each other. Metalloids, what makes them unique is that metalloids typically have properties that kind of fall in between metals and nonmetals. In other words, a metalloid could have metal properties and nonmetal properties at the same time. So they can have a combination of both. So boron, for instance, at times will have properties that are similar to metals, and at other times will have properties that are similar to nonmetals, okay? So there we go. Now, metalloids also, by the way, are sometimes known as semi-metals because they sort of have metal properties, but they also have those non-metal properties, okay? So just become familiar with this table and the properties here, all right? So that's good for the time being. Now, one last thing that I want you to do and that is on the periodic table. You have this in your note. The periodic table has some special group names, okay? So the group names are listed under here: alkaline metals, alkaline earth metals, halogens, transition, noble gas, so forth and so forth, okay? You're gonna actually take this table and use like colored pencils, and you're going to color code your periodic table. Now, the color codes can be similar to this slide right here. All right, so you can use kind of the colors here, the alkali metals, which are right here, other than hydrogen because it's a non-metal and is classified as a non-metal, as you can see here. And then you have the alkaline earth metals. The transition elements are here. The lanthanides, the alkanides, so forth and so forth. The noble gases are here, the halogens are here, and so forth. So essentially what I want you to do is use this periodic table here that's in the video and essentially color code the periodic table that's in your notes as best you can, okay? If you have questions or concerns about something, then come to class and I'll help you with it and all of that, okay? But you should know these special group names for these unique groups and where they're found on the periodic table, okay? So that's it for this particular lesson. So study hard, study your study guides and your notes here for this lesson, and come prepared to discuss more about the periodic table. And honestly, like I said earlier, it is a process. You're going to be studying the periodic table and adding to your understanding of it throughout the year. Okay, so that is it for now. We'll see you. Take care. Bye-bye.